Hello again, it's Duncan. Today on Team Gilded Rose, it's time to get on with updating the quality of our magical items as time passes. Now we'd like to start by writing a high-level test to show what we want to happen. And this should start up the app, make a request, and that's pretty much what our existing list stock test does, so we could just copy that. But this stock test is already collapsing under the weight of this late init and lazy properties. So maybe we'll fix that first and see if we can simplify this as a good starting point for other tests like it. What we're going to do is extract a test fixture. And a fixture is the state of a test, the thing we're testing if we have a class under test, and the things that it cooperates with. And in JUnit, the fixture is normally the properties of the class under test. So what we're going to do is we're going to take some of those and make a little class of them. And in order to keep access to them, we're going to make it an inner class for now. So we're just going to surround these by inner class fixture, like that. If we do that, these are not then accessible here because they're now inside this fixture. And we need to create an instance of it. What we're going to do is we're going to create that in a with statement so that it's still a receiver, and that will mean that this code is unchanged. But now these need to be public parts of our fixture. So that fixes that one. And we can do the same thing in this test. And run that. Okay, that's quite nice, but we'd rather not have these as lazy, so we can fix that, can we? Which was kind of the point of going in. Change to ordinary property. Change to ordinary property. That still works because we're only creating a fixture now after this tempter has been initialized. We can do slightly better now than an inner class by passing the directory into the fixture when we build it. So we're going to have a directory here as a property, and that means we'd have to pass the dir in here and here. But now class fixture is no longer an inner class, which means that we can extract it into the upper level. And let's create its own little file, shall we? And we'll just pull that over there so we can have a look at it. Now we've got this code in one place, we can add conveniences to it. So for example, the standard stock list save to file, that happens in both these places. Well, it sounds like then what actually our fixture wants is the ability to be created with the contents of that standard stock list. So we could say initial stock list, and in our init code in here we could say init stock list dot save to file, and that's our stock file. In order to make that work, we just have to pull that up there. Now then, we can move these into here and say a fixture takes a stock list, stock list, in this case a standard one, and makes everything ready for the app to work, ready for these routes. Here also we are saving a stock list, and we're having to delve into the stock file inside here, but you can see equally well we could have a method on here which was fun save. This would take a stock list, and this would say stock list. This would be our stock list saved file. We could have extracted it, I suppose, from up in our init. So we could say init is actually save initial stock list. And now over here, instead of delving down into my stock file, I can say fixture. Don't have to say fixture, I can just say save. Oh, but I've lost that stock list, so I'm going to say save that empty stock list. One more. Okay, that's quite nice for now. Let's commit that. Maybe just pull a little bit of formatting in there. And in fact, before we do, let's just have a look at this. We have an opportunity here, I think, to not use this temp dir at all, because here we could just create a temp file. So in fact, let's skip the stock file altogether. If we pull stock file to there, we say stock file is files.create temp file. We get the prefix of stock and the ending of .tsv. And that returns a path, so we need to say to file on it. Now, we don't need to resolve that. We have a stock file which needs to be can now be a private val. And now instead of passing any directory in here at all, our fixture can manage a private directory for us. Now our temp dir goes, and we have a nice little abstraction we can build on for other tests. Let's commit that. Introduce fixture to simplify tests. There are two warnings. Should we see what they are? Seem to be in here. Let's click on that. Unused imports. Well, we haven't got that set to. There we go. Run that. Good, good, good. Commit. Commit. Now we've done that, let's think about our update stock tests. We're just going to copy this wholesale for now and call it update stock tests. Add that again. Okay, I don't think we're going to worry about approvals in this test. We'll get rid of that, and we'll get rid of these approvers. And in fact, let's just get rid of this one altogether. Okay, so this first test is going to say that it doesn't update when last modified is today. So, and then we want a similar thing which says it does update when last modified was yesterday. So those are the things we're trying to get working. And that begs two questions. What does it mean to update, and what does it mean for the last modified to be sometime? Delete both of those for now. Get ourselves in a compiling place and just check that obviously those tests should pass. It's not actually asserting anything, are they? Okay. When last modified is today, let's have a look at what our standard stock list looks like. Because we have some sort of date that's passed into our application at the moment. That you can see that over here when we say roots for, we have roots for with some calendar, some way of getting a local date. So that's now in some sort of sense. And we have the last modified date that is the last modified date of our stock list. So that's this thing here. We can make that a bit clearer by saying, putting the names in. And now we look at this, it's a little bit odd that we create a stock list with instant now, because that changes every time we create a new standard stock list. It'll be different every time we run the tests. So that's a little bit suspicious to me. I think I might say, let's try and keep our tests potentially a bit more stable by just creating some sort of variable that represents that thing, but that is constant between our tests. So let's make a variable here, and we'll just call this sum instant. And instead of saying instant now, we'll parse out sometime, and today is good enough as any. So that's 2022. It's February. It is the 9th. And for dates like this, given nothing else, I'll put the minimum of the day like that. And we'll say that is UTC. And Kotlin's complaining that it doesn't know that instant parse doesn't return a nullable thing, which is a little brain dead, but let's specify that to be instant. So if we're lucky, that won't affect any of our tests, and they also pass, so that's good. Okay, just drop that down there so we can have a little look at it. So when last modified is today. So let us create ourselves a fixture here, maybe more explicitly. Let's create ourselves a stock list more explicitly. So let's say this stock list, the one that we are going to save to disk. Let's take our standard stock list and copy it with the last modified under our control. So not just any old time, but one that we know. And this one will do, but it means that we can see what we're dealing with. How do we affect now? Well, our calendar here, the thing that we're using to return October 29th, we're going to need to be able to parameterize that in our fixture. So I suppose we'll put that in here, and we'll say, in order not to break any code, we'll say this is what we've called it now, so val now, which is a local date, and we'll make that October the 29th by default, which will keep everything running, but we'll put it in there. Maybe we could have extracted a constructor parameter for that. That shouldn't break anything, and should allow us to say that when we build this fixture that we want to use, we want to specify when now is. So when last modified is today, then the now that we want, local date, parse. I'm going to parse something that's the same day as this. Now, we're going to have to worry about time zones at some point, but let's just not worry about that just for now, just in order to express what it is we're trying to solve here. So, if we start with a stock list and we save it, and then we read it on the same day, what we expect is that nothing should change. We shouldn't update the thing on disk when we make a request. So we'll make that request, reminding ourselves how to do that by looking in the list stock tests. So that is root request get. In fact, we have one here that says just check that we get anything back from it. So let's try that. It says we make a request, that should return OK. And then if we were to look in the file, we would see that it hadn't changed. How can we look in the file? Well, maybe we could ask fixture to load it for us. So we want this, we want load that returns a stock list, and that should return stock file dot load items. And so in here, this should be able to say cert equals the stock list that we saved should be what happens if we ask the fixture to load for us. And that is the behavior at the moment, so it should pass. What's the counter behavior? What else do we want to happen? In that case, we would say we could keep the same stock list here. But now, what happens if we read the day after the last modified? So this was last modified on the 9th, so we want to pretend we're going to read on the 10th. In that case, we should still get that okay when we make a request, but let's not worry about how we change the stock file, how we change the stock list. Yes, but we should be able to say that is not the same. Okay, so now you can see that we have a failing test. It's going to take us a while to implement this behavior, but when we have implemented behavior, this is a marker for what we want to happen. We might come back later and tighten up this to see what it actually should be, but for now we can just say let's get ourselves somewhere by disabling this test. And we'll disable that with WIP for work in progress. Okay, so let's us commit that. So this is add update stock tests, and we'll actually specify that they are work in progress. One warning, we're just going to check, and there's an unused import somewhere in here. Okay, that's a good place. Before we go on though, we just have a look at this and see whether it's communicating well enough. And you know, I'm not convinced that it is. Part of the problem is that what is the difference between these two blocks of code? They look identical. You have to look inside them and see the difference between this equals and not equals. Well, maybe that's okay. But also you need to parse all these dates and times out to see what they mean. So we'd like to see what the difference is. So one nice way to do it would be to make this into a field. If we just pull this up into here, then we know that that's common in between both these tests. It can be private. And now, instead of just saying now here, we'll say, let's give this a name here. So this is, we could call this one a variable, which is same day as last modified. And this one we can say is next day from last modified. And that at least allows us to see more easily what's common and what's different between these two tests. So that I think is quite a bit nicer and will help us when we get back here to remember what it was we were doing. We'll commit that, amend commit maybe so nobody ever sees it. And now we can get on with our work. Now, what should be responsible for updating the stock? Let's go back to main and just see what we actually do when we run up the code. And the answer is every time we make a request, then we load from the stock file. So what I think I propose is that instead of doing that here, we ask something to load the stock file for us, and that thing, whatever it is, can decide that it needs to not only load the stock file, but update the stock items and save it again and that will then be transparent to the code that we have, and that can be a place that we can apply whatever strategies we have for updating, and all that logic can be hidden. I'm going to call that stock. So I think what we're going to do is we're going to create a test which is called stock tests. And at the moment we have this thing called stock list, and stock will return a stock list for us. So if we ask it, it will tell us what the stock list is like. The stock list is a value class. It shows us a point in time, but stock will be a thing that fetches the latest version. It's a place where we can update stock. Okay. I think I'm going to try sketching this out without writing any tests, just to see what it feels like. So my idea is that we would end up with a class stock that knew where the stock file was, had that as a property, and that we could ask for the stock list. So it would be a function, and it would return us a stock list. Don't know how to do that yet. Well, actually, we do know how to do that. But let's pretend that we don't and write a test. So we're going to need a stock file, and we tried that annotation, the JUnit annotation. It was a bit nasty. Let's not do that for this time, and we'll just go straight to our nice creating a temp file ourselves. So in our stock tests, we can say that's our stock file, and we can create ourselves a instance of stock, giving it the stock file and equals. And we'll just say we'll create a test which is loads stock from file. Now we've got a fixture that will manage some of those things for us, so we can also now say what does the fixture need? It needs an initial stock list. So we can give that our standard stock list. And in fact, if we do these the other way around, we know that a fixture is creating an empty place for us. So in here, we can ask the fixture for its stock file, which we made private, but I don't mind being public. So now we've got a fixture managing the stock file from our test perspective, and we've got stock managing the stock file from our potentially production code. So what does this mean? Well, it means that if we ask the stock, let's go the other way around, it means if we ask the stock for the stock list, then that should be the standard stock list that we put in. The one that we saved to file by creating the fixture. Am I right about that? I don't really know. Let's run all our tests and find out. Well, we've still got this to do. We know the answer to this, of course. It is that we take the stock file and we ask it to load its items. Okay, that passes nicely. So now we have a place to put code in between loading the items and returning the stock list. So now we have a place to put code that will look at today's date and the last modified of our items and decide whether to update the stock, the qualities of the stock. Let's write ourselves a test, try and sketch out what that might look like. Update stock if, I don't know why IntelliJ thinks that's a good idea when I'm typing into a method name. Last modified yesterday. Okay, how would we know it was last modified yesterday? We could give stock a clock, some way of asking the time, or we could tell it when we're asking. And I tend to prefer telling when we ask it so that we can see what's going on. So let's give this a parameter, which is when we're asking. This means that we have to specify what we consider the time to be when we make this call. It means we'd have to do it here, but that's fair because we have to differentiate in these two tests what the difference between them is. Let's also, though, try and gain some control over when our last modified is, because when we've got this sum instant, which is all a bit opaque to us in this test. So let's pull the standard stock list out from here as a variable, and we're going to call that initial stock list. That will do fine, but we'll pull it into this test as part of its code. What we're going to do is we're going to copy and we're going to give it a last modified instant.parse. Just formatting first, and then we'll pick today again. Okay, so now we need to pick some sort of time, and because we'll be looking on boundaries of things, maybe the end of a day would be a good idea so that we can load it the very next day by a second, maybe. So 23, 59, 59, and we'll specify the time zone of UTC. And something's gone wrong here. It seems to have moved that, so that is okay. So there's our initial stock list with a particular time, and if we load the same day, then we expect to see the same stock list back. That's this case here. So what we say is val now is this here. And so if we do that there, we expect the same stock list back. But the next day, if we were to go with the 10th at 000001, we'd expect the stock list to be updated. And what we expect to see? Well, at the very least, we'd expect to see the last modified being set to this now here. So what we expect to see is the initial stock list.copy with its last modified is now. So that's the difference between these two situations. So that fails because we have no code. Let us think how to implement that. So we are now going to say, let's load the items, and let's put that in a variable for here. We'll call that loaded. And the question we want to ask is if loaded dot last modified, and we want to ask how many days there are between them. Not just whether it is yesterday, because if we ran up 3 days after we'd last modified the file, we'd want to apply 3 days worth of changes to our stock. So we want to say something like days between that and now. If that's 0, then we want to return loaded. Otherwise, let's not worry about how we actually affect it at the moment, but let's take our loaded and let's copy the code that we had up there, which is now. And as this says, it's not compiling, but it's a nice expression of that. Okay, that just leaves us with loaded last modified days between. Let's pretend that exists. So we'll create an extension function which is instant days between now, and we can call that then. That's going to return an instant, and it's going to take an instant, and it's going to return a long. Now, this is going to take some work. At the moment, I'm going to fake it. So in order to test my test, I am going to say if then which is the now that we're passing in here. So we're just going to say if that's the same as that, return 1. It's 1 day. And let's keep ourselves, otherwise if it's this, return 0 days. Now this is completely cheating. So we'll make sure that this can't go into production with, well, in fact this is to do, right? And we have a small problem here, which is that I think that expects an L. Just see whether that, though, passes our test. And it does. So we're now in a position to maybe tighten up our test a bit as well. Not only do we expect that the stock list that's returned has been updated, which say the last modifier has changed, but we want it to be saved to disk as well. So that we can ask the fixture for. So we can duplicate this and say that that stock list is the fixture. We'll ask the fixture to load the stock for us. And that will show that it's been saved on disk. The test will fail until we say what we're going to return is this, and we can say also it.save to stock file. Now this is obviously all way too hard coded, but it's at least giving us a test that we can now refactor our way out of. This is expected updated result. Okay, one last little tidy up in here. We can make this a nice when. Lift the return out of the if and make it into a when. Now, days between two instances is not a trivial piece of code. So we are going to take a break, and I think probably come back to that in the next episode. So I will just make this expression body, but that doesn't mean that we can't commit this code. It will be an opportunity for other people to have a look at it, and us not lose it if our machine died. So let's run all the tests. And because stock here is still in our test tree rather than in our main tree, nobody will be tempted to use it until we fixed it properly. Okay. Receive parameters not used. That's because we have gratuitously hard-coded things. Let's commit this with commit anyway. And next time we'll have a really hard think about how we work out how many days there are between two instances, which is effectively how many times there is a midnight between two instances. I hope you've enjoyed this. If you have, then you will probably like the book that I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook. And if, like me, you can't wait to see how this ends, please subscribe to the channel and you'll hear when the next video is released. Thanks for watching.